Okay, think about this for a second. A farmer, right? Seeing their crops just decimated by like a hidden ant colony, or maybe it's closer to home, that endless battle in your own backyard. You keep spraying those broad spectrum chemicals, and let's be honest, they often do more harm than good environmentally. It's a huge problem, isn't it?
Oh, absolutely. It really is. I mean, conventional pest control, it often feels like using a hammer when you need a scalpel, a bit of a blunt instrument.
Yeah.
So there's this clear, urgent need for something smarter, more targeted,
Yeah.
and definitely more sustainable.
And that is exactly what we're going to dive into today. It's this really radical new concept, an autonomous ant eradication robot. We're going to get into its feasibility, the really clever design choices, and the whole plan to bring this thing to life. So you're about to find out how this robot could offer a much more precise, kind of environmentally conscious, and automated way to manage pests, moving away from just, spraying chemicals everywhere. So building something that precise and autonomous too.
The foundation's got to be solid, right? What's actually underpinning this little pest destroyer?
Right. So it's actually built around a modified Traxxas RC truck platform, which sounds maybe simple, but it's kind of a stroke of genius.
Okay. Why that?
Well, it's super durable, for one, but also using readily available commercial off-the-shelf parts, COTS parts. It's not just about keeping costs down. It's a really smart way to speed up development. Makes cutting-edge tech much easier to deploy quickly.
Makes sense.
The big engineering challenge, though, is really expanding that base frame. It needs to carry quite a sophisticated payload.
And the brains, I mean, tracking something as tiny and fast as an ant, that seems incredibly difficult.
Yeah, that's where the real innovation kicks in. Its intelligence comes from Raspberry Pi controllers. Think of them as tiny, powerful computers right on board. The brain, basically.
Exactly. That, combined with advanced computer vision using frameworks like OpenCV, that software is what lets it actually see and identify ants, precisely and in real time. It's specifically designed to track individual ant trails right back to the colony. So the intervention is super targeted.
Okay, so it finds the nest. Then what? How does it actually deal with the ants? What's the attack plan?
Well, the clever part is it's not just one method. It's got this sort of multimodal approach. Three things, really. First, precise killer bait deployment. So placing lethal bait directly along those trails it's identified.
Right at the source.
Exactly. Hits the colony where it lives.
Okay, but what about the ants still wandering around? The scouts.
Ah, good question. That's mode number 2. Strategic repellent application. It lays down a line of natural repellent, specifically rosemary oil, to manage their movement.
Rosemary oil, huh? Natural.
Yeah, helps prevent new trails forming while the bait does its thing. It's about containment.
And you mentioned 3 modes. What's the third?
Right, the third is, well, it's kind of cool, a high-accuracy salt gun.
A salt gun? Seriously?
Yeah, using salt as a non-toxic, kinetic last line of defense. For individual ants, or maybe to disperse a small swarm, think of it like a tiny, very precise, salty shotgun blast.
Wow. Okay, bait, repellent, and salt. Quite the arsenal.
And what ties it all together, what's really fascinating, is the automation. This little robot is designed to deploy from and return to a larger mothership system.
A mothership?
Yeah, think something about the size of a utility trailer. And this mothership handles everything autonomously. Refilling the bait, the repellent, the salt, even recharging the robot's batteries.
So very little human intervention needed.
That's the goal, significantly reducing it. It's designed to be almost self-sufficient out there.
So the vision is you press start and just let the robots handle pest control. It's a huge shift. What about, the practical side? Is it actually feasible? What about the cost?
Well, technically, yes, it seems feasible. Relying heavily on those COTS parts really helps manage the costs. We're estimating the prototype cost somewhere in the range of, say, $10,000 to $25,000. But the final production units, they could potentially drop to maybe $2,500 to $5,000 each.
That's surprisingly affordable for what it does.
It is, but there are definitely challenges. Integrating everything, and especially getting that real-time, high-accuracy detection of tiny, fast ants in different lighting on varied terrain, that's a significant engineering hurdle. The estimate for a working prototype is probably around 12 to 18 months.
Right. So what's the big takeaway here? So what, for you listening, this isn't just some cool gadget. This autonomous system could genuinely revolutionize pest control. By being, environmentally responsible and highly efficient, it offers a real intelligent alternative to just dousing everything in broad spectrum pesticides.
Yeah.
It's moving from that blanket bombing approach.
To precision striking.
Yeah.
Exactly. So just to recap quickly.
Yeah.
We've looked at a real innovation here. targeted, multimodal ant eradication using smart robotics and, crucially, automated support. It's this blend of high-tech thinking and practical, sustainable goals.
Yeah, absolutely. And maybe here's a final thought to leave you with. As you consider this specific robot, think bigger for a moment. How could this kind of precision robotics change how we tackle other big environmental or agricultural problems? What other complex issues could be solved if we move towards more sustainable, more automated, hyper-targeted robotic solutions like this one? Something to think about.